So yeah, so we asked a couple questions. This is the first section of the term. And essentially what we're doing is, as I told the students in a brief Q&A, or less than brief, about a 20-minute Q&A, is essentially some aspects of the course syllabus, and then also when we will talk about the final project. And I think that it's increasingly important, and I think it's good feedback to think about the final project as early as you're welcome to. So to that end, I have a plethora of data sources. I have a lot of other tutorials on importing your data into R, which I think is the most difficult part. But generally speaking, when I talk about these sections, I think about this section that I'm providing right now as the more syntax-oriented session, and the other session that I have this week as a more conceptual overview. I think it fits both sides of the coin. The conceptual overview is important for obviously answering the questions and understanding them. This is where an English degree is very helpful, because it's all about interpretation. What is really meant when we have a particular indicator? How do you tell a story out of this? What are some flaws with the story? And then when we talk about what we're going to do today, which is the quantitative syntactic approach, it's more about how do you get from point A to point B efficiently, and doing it in a way in which you have an audit trail, you can reproduce the results that you have, you can show your code to others, you can improve your analyses, and you can choose analyses and data that reflect the story that you want to tell. And in terms of math and probability, we go into just enough to get you started, but nothing more. And that is to say, we get you oriented in the most fundamental approach of in the most fundamental, I think, contribution of modern statistics. You have inference. What is inference? Well, it's to take a body of data, a sample or a portion of data, and have that data with some assumptions, but with some also adjustments, have that body of data tell us about something that is not within that data, but speaks to a larger population that the data represent. That's what inference is, right? If you just think about it colloquially, I infer from what the person has told me. You can think of a witness in maybe a courtroom. You can infer from the witness by their testimony what actually happened. Well, in statistics, we infer from a smaller sample what actually happened with a larger population. And that is in the second half of the course, after about week 6 or 7. And that requires more on probability and statistics. And there's some simple math there, but there's less simple or intuitive interpretations of logic and probability. And that's extremely useful. This is about thinking clearly. In an era of false news, false statistics, false science, false positive research findings, the second half of the course, and even parts of the first half, will fine-tune your critical thinking skills so that you know what exactly is meant. And the mathematics that are assumed are basic adding and subtracting. Everything you can do on a calculator with a humanities degree. So that's not saying it's easy. Logic and critical thinking is difficult. So what are we doing in the first half of the course if we're not doing inference? Well, we're doing something more fundamental, which is describing the data at hand. How do we understand what we have? Because you have to understand what you have, what the data can say, before you can speak about it later. I hope that helps, but I think that's the way to think about the course. First half of the course up until the midterm, describing what you have. Second half of the course after the midterm, inferring what you have given what you've described. So the second half goes beyond the data. And then the final project is an exercise of your own choosing to take what you find to be valuable to translate and tell a story out of the data. Make it meaningful to people who are intelligent, but who are also critical. And that's, I think, I view it as the most important part, especially if you're in graduate school, but also if you want to exercise critical thinking about statistics, because we're all telling stories. Okay, that's sort of that approach there. And that's how I think about pedagogically the contributions that I hope to provide in this course. One is getting you the machinery, the programming languages to do the analyses, and then going from there, and as we'll do in the next section, thinking critically about what they mean. Okay, so first one is we'll draw on your programming savvy for those of you who are dedicated programmers. And the second part, we'll focus on the inherent ambiguities. So, okay. All right, I know that's a repeat for those of you who have attended. I appreciate that. So given that this is our first problem set for this term, our first mission, I'm actually going to do something a little bit different, which is I'm going to run through the code as I've done in previous terms, just so if you have any questions, please feel free to chime in and tell me if you have any questions, because my biggest concern at this point is I just want everyone to have their, what we call the sandbox, your sandbox where you can actually play with the data, where you can actually understand everything, where you can understand the interface, the graphical user interface, but also the coding interface for RStudio. Now, unfortunately, before we get there, we have a whole bunch of questions that I've fielded, but these have to deal with, did I install R? Did I install RStudio? Did I find help? What is a package? What is a, why do I use the library function? Are there any questions about that? So I see it in two sections. One is getting our stuff installed, ready to go. And the second half is I'm going to run more quickly, get your code up, and let it run. The first half, I think, is far more problematic, but I think we addressed it in the earlier week. Is there anyone who has not yet, and no shame at all, no shame in your game, you can message in below. This is helpful for me. Or is there anyone who has not yet installed the software or who has encountered difficulties with their software but not addressed it to me or to anyone in the discussion board? No? Okay. All right, good, okay. So to be fair, everyone has installed. Okay. Are there any questions for those of you who have not? Okay, not quite yet, that's fine. For those of you who have lingering questions, we're gonna pin that questions about R tutorials, or sorry, RStudio for quite a while. And those questions aren't gonna go away because R evolves, it's a kind of a user source code. It's not, how do I put it? It's not necessarily the only code you're going to use, but it is important. It's not just important for the class. This is my last little soapbox because I know we're short on time, but it's also important for data science. It's great for your CV. I mean, major data analytic firms, much of academia uses R. It came out of Bell Laboratories, and it has kind of a sort of a storied history. And it has some limitations, but it's great for doing advanced, interesting statistical analyses. So, okay. And I understand that. No rush on that, because here's the deal. As long as you follow the tutorials, you're able to understand how to install the software. And I think that's also in the how do I put it? That's actually also in the, you might not see me for a second. That's also on the module where we talk about our tutorials. I want to take you to that. Just because I think there are some, places where you should bookmark, I think, places for help, but I encourage you to, well, I won't get to that now, actually. So what I'm going to assume here is that if you read my first announcement last week and my 16-part R tutorial video on YouTube, skipping the parts that are not necessary, you should be at a point where you're going to have something that looks like what I'm going to show you right here, which is in essence a R installed, RStudio installed, something called the Mosaic library installed. It's called a package, rather, a package that is installed. And those require your machine to be web aware or for you to use some cloud service that is online. All that means is that you've installed basically the motor of the program. You've installed the wrapper, or the kind of the graphical user interface approach, the operating system, you could say. It's nice and shiny. You can use drop-down menus. It's easier to interpret. It's what I will teach in this course. Then you have these things called packages. These are essentially additional material, additional kind of goodies. They're like add-ons. I don't know how, maybe an analog might be I'm not really into video games, but I know a lot of people are. If you're playing one of these online video games, like Electronic Arts has these, in the latest Star Wars game, they have like loot boxes, whatever those are. Those are add-ons, I guess. You have to pay for them, of course. But those are add-ons to the games to augment the gaming experience. Well, what this does is there are a bunch of packages that are written by the R community. Some are better, some are worse. You basically install those, and those packages basically give your R superpowers. That makes it do really cool stuff, as long as the package is kind of well regarded. And that's kind of the logic there. Of course, it's free. Now, in programming, I've heard of this quote, there are two kinds of freedom. Free as in speech, free as in beer. Free as in beer means that the software is free. Well, R we use, and the reason it's used ubiquitously among the best statisticians, it is free as in beer. It does not cost a dime. It is something ordered for you. Free as in speech means that anyone can write a program. So in that sense, anyone can write these quote unquote packages, which think of these as additional programs, kind of like, superpowers essentially. And we're going to install one package, which with a lot of additional kind of what we call dependencies. And all that means is that you have that package here, and it has a bunch of other packages it relies on. So it'll install those as we see that. Okay, so you install the packages, and then from there you have you can basically invoke the package or use the package each time you open R once it's been installed. But you have to tell R that you want to use it, because whenever you reopen R without saving, which is I think going to be typical for us, we're not going to assume you're going to save anything. You're going to start over. You're going to use something called the library function. And all that means is, okay, I bought my packages. I'm going to my own personal library. I'm going to pull this package off the shelf and use it. And that's why you're going to always see this library Mosaic package, because that's the package we use. It's the syntax we follow. It's not the only syntax that we follow. And I apologize to those of you who are dedicated programmers. This might seem a little simplistic or perhaps even a little erroneous, but that's the downside of an analogy, a partial comparison. It provides insight in some ways and is detrimental in other ways. I'm going to show that to you fairly briefly, just the installation packages and some websites to go to. And then I'm going to show you what I hope when you open and do your first analysis, and when you do following analyses, what it should look like. So let's start out with, actually I'm going to start out with the opening up RStudio, and I'm going to share my screen, so you might not actually see me. Here, you might see me in the upper corner. So Let's see. Pardon me while I'm just typing up a little bit, because I want to get us to what I call our working directory. Okay. So let me share the screen. You should be able to see this. Let me know if there are any issues. And as usual, if you have any questions as I'm speaking, chime in, chime in. You may either interrupt me and speak, or you may, you know, type in the chat. Although I may not see the chat here. So, okay, now you should see RStudio here. A couple things here. You don't see anything in the upper left-hand corner, but you see what are called pinned panes. This is actually one window on my desktop. I could probably even share my desktop if you can sort of see the broader context. I think that'll be useful for you, actually. So I'll stop this share and do a new one. Yeah. Okay. Can every one of you see everything aside from maybe the chat box or maybe the Zoom screen? I just want you to see the desktop.
Yes, we can. Thanks.
Okay. Are you seeing the chat box?
No, I don't think so.
Okay. I just want to make sure that was hidden, just for privacy's sake. Okay. What I have here, if you notice, here's my desktop. Here's a nice picture, whatever. I'm on a Mac OS X, and you'll see that right here, actually. If I can erase some of this gobbledygook, you can sort of see right here. When you start R, my R starts right in the desktop right here. That's what I encourage you to do, to basically, I guess you could say, load the workspace from the desktop, but it doesn't matter. As long as you have one place where you load. And the reason I say that is you want to make sure that it's like a camping trip. You want to make sure that if you're going camping and then you go on a hike, you want to make sure you go back to the same campsite. And you're going to have a stat E100 campsite. You're going to have a statistics campsite here. I'm going to have my statistics campsite be the desktop because it's pretty transparent. And you'll see what it looks like. I have a to-read folder. This is my own personal folder of stuff. I have some stuff on machine learning and Judea Pearl. You know, this is just personal, but you know, if you have things you're interested in for the final project, it might be useful. But what I have is I have a folder here, pset1. Call it what you want, keep it consistent. And in pset1, I have two things. I have, just going to keep it simple. View, you should look at these as two icons. I have the R problem set code and the Titanic R data file. These are both downloaded directly from the website. My code is slightly altered because I've done some annotations and helped students. My Titanic data set is identical. Two things to notice here. The R code ends in a capital R. The reason is that this is the R suffix to tell us that this is a script file. Just as say in a play, the playwrights, Arthur Miller wrote Death of a Salesman, and a famous American play. Well, he wrote the script. The script tells you what to do. Well, we don't have actors here really, but we do have that to which the script is applied, and that's the data. Those are the data, excuse me, right? Data are plural. And that is in the R environment, this is called an R data file, and it is a capital R, capital D, lowercase a, lowercase t, lowercase a. So keep those two things in mind. No, I don't want to open it. But the main point here is that this is what we're going to give you every single homework assignment. Nothing is going to change. The more things change, the more things stay the same, the more the content changes. The reason is, okay, we can show you code, and anyone can find code anywhere, but we want you to get used to using the code first, get used to thinking about it, and then stray off if you want to do whatever works. But at the bare minimum, to answer the problem sets, you will need to have something like this. You'll need to have the R script and the data file, and those are downloadable from the problem set. Those are in part 2 of the problem set that refer to data analysis. And those are useful to you for, I think, actually I know, for understanding the concepts. And if you're going to use R in the final project, it'll also help provide you with, I think, a wealth of resources to do interesting analyses and upload data. But the point I have to make is R data files don't upload any kind of data file. They only open data files for R. So if you have any other kinds of data files, we will talk about those pretty soon. Some of these are called CSV files, comma separated files. There are Excel files. There are other kinds of files. We won't worry about that just right now, but I'll try to push a discussion on the discussion board toward the final project sooner than later. I appreciate that. Anyway, I call this data hygiene because basically the way I will do any kind of project and do a write-up is I will always have my code and data in one location. Actually, technically, I'll put it in one location, right? I'll actually have the data somewhere and then I'll have the script somewhere, but let's just keep things right where they are in the same place. And the reason we do that is we just don't want to change places. We don't want to save our data files in different places. We don't want to change anything and make things a little too confusing. So now that we know, and basically what I did here to get here is I dropped down the data set. I saved the data set to my downloads folder. I saved my syntax to the downloads folder, and this is part 2 of the problem set. And I saved them to this file that I named pset1. And I would keep it, parallel, pset2, pset3, whatever you want to call it. And let's, I'm going to close RStudio. And if you look on my, well, here I'll look for, if you look at my doc here, you'll see quite a bit of other things here, like other kinds of ways of analyzing data. But I'm going to open up, here's the RStudio thing. You notice when I click on the RStudio icon, it'll always open up. Now, several students, especially when you're starting out, you may open up what is called base R. Well, we don't necessarily want you to do that. And there's a workaround for this. This is a very common problem because remember you install 2 kinds of R. There is a base R. Let me stop the share and I'll just get us to sharing. Oh, sorry, someone had a question. Please ask a question if you may. I'm sorry, I didn't see that.
Hi, Professor.
Hi.
Hi,
Jennifer.
Sorry to interrupt. So I completed the mission, and I was just curious. So when we download the code, the pset R code, what does margins equals true do in the code?
Okay, that's a great question. Basically, it's a little technical, but there are things called arguments. It's a sort of an, we'll get to that, I have that down. Okay, before we get there though, so here we have sort of an organized environment. I encourage you, especially for those of you who are new, to use the drop-down menus for finding your files. So I do just file, open file, right? And then you can go right here. It'll go to your desktop, or you can navigate to your desktop. I see there's another question, which is fine. Yeah, this there, someone has a nice response here. Thank you for that, Steve. So basically what we have is we have the problem set 1. This is already at my desktop. I know this, but you may have to navigate, get to other parts. But I want to set my place here. I want to actually even open up this code here. And then I want to open file. And then I'm going to open up my R data file. And I'm going to just click here and click open. It'll ask, do you want to open this? It'll have a little sort of either a complete or sort of partial, full or partial path file. A path file is simply a bit of script or text that tells you where your file is located. This little tilde on a Mac says, oh, it's blah, blah, blah. It's where you already are, plus your desktop, or your desktop, plus where the desktop is located. But you got to go to problem set 1 folder, and there it is. And look at this right here. If you go to your tabs in the upper right-hand corner, these basically tell you what you have in your R environment. It's like your sandbox. There are more tabs down in the lower right-hand corner. These are more for uploading packages, looking at files. Another way to upload things are to click on that folder there. But those are for your exploration from later, because I know I want to get us into the nuts and bolts of using your script. But the main point is that you have in some panel, and this could change, you have a panel with the R script, and you know this because it has .r code here. And then you have the console, and this might look more similar to base R. What I wanted to say, and I'm sorry I went on a tangent here, sometimes for many users, actually quite often for many users, they will install R and then they'll base R and then they'll install RStudio. But whenever they click on, say, just the script file without any other kinds of adjustments, they will open the script automatically in base R. You actually want to change the permissions so you can open your script so that it always opens in the file that you want it to do. In a Mac, the options are a little bit different, but basically, if that's an issue, feel free to chime in and I will actually address that question. But basically, you can change your folder permissions, but just make sure that you're always opening a .r file in RStudio, not in base R. Okay. So what we do here is that this little chevron here is basically kind of like in DOS operating system. We have a blinking cursor. Now what? Now what are we going to do, right? It's like one of these old text-based games. If you've ever played Zork or one of these older kind of canonical games back in the 90s, or if you're into the old programming stuff, this is a pretty fundamental place to do a lot of coding. The problem is it doesn't save your code. This is why we rely on scripts. You want to write your scripts rather than type interactively. That being said, you can actually do quite a bit here. I mentioned I had a little disquisition on installing and packages and using a library. This is called loading a package. And remember I talked about installing packages? That means buying the book for your library. Technically speaking, if you want to augment your brain power for your software, you're buying this, you're downloading it from the internet. You're buying it for free though. And the library is sort of like taking what you've already installed and pulling it off the shelf. So I'm going to go through Gui commands here. You can highlight this. You can press the cursor right here, right at the end of that line. And you can press run to run that code. It'll run that line. And R is pretty helpful, at least in the Mac environment. You can basically run that. Or it looks like you can do a keyboard shortcut too. But I'm going to go just through GUI. You can click a run, and it'll highlight that right here, and it'll run it. You'll see a lot of scary red text. No worries here. And it looks like I installed this. Keep in mind I installed this earlier just to test compatibilities with the most recent version of Mac, the most recent version of R, the most recent version of RStudio, and all of it works. So I don't really need to install this anymore, so I can comment it out. I'm going to press the hashtag, like Shift 3 on my Mac keyboard, QWERTY keyboard, and all it does is that comments out text or commands that I don't need to use anymore, script. So I'm going to press Control or Command S, and I just save that script, so I don't have to run this install packages library, install packages Mosaic anymore. And now I can just load the package into R, and you have to do that every time you open it up. So let's do that. And you can look here, there might be some danger issues, but these are what I call dependencies. There's something called the dplyr package, some other things. Lattice, don't worry about these right now unless you're really interested. But basically, the red text should not be an issue. But if you're running into problems completing or evaluating your code, I would look for that first. We provide you with maybe I think a modified load command to load the data set here. Keep in mind that you should know where your data set is, and you should load this Titanic data set. Do not simply type load Titanic. Oh, maybe I should type this. If you go to your environment, you'll see what you have here. Well, it looks like I should be importing the data set here. Are there any other questions? I haven't necessarily been looking at that. I apologize. Some of these are hidden away. Thank you. Hold on. Oh, I don't see any other questions. If there's someone I've missed, please let me know. Anyway, the point is, do not load the Titanic data set that is actually installed within R as an example data set. You want to load this data set, and I know it's for later, but basically load what it is that you're using, and that's why I encourage the drop-down menu first. You'll see that sometimes it takes a while to actually load a data set, or data frame, by the way. In R, we'll often talk about what are called data frames. And this is taking a little bit more time than I would have liked, but we'll see why. Well, while we're at that, I can give you kind of a quick tour of R. But basically, once you run, before I kind of spend the last few minutes just kind of showing you R, I do want to emphasize, sometimes it takes a little while to actually load the data frame. I think it's because I actually have some other parallel analyses that could be slowing this down. Could be my internet might be throttled, who knows. But in one of your panels, you'll have a nice little place for you to look to see what it is you've loaded up in your environment. What do you have in your sandbox, to be kind of colloquial here? Well, so far, we don't have anything, right? We just have the Titanic data set that is supposedly loading and should load. Although maybe, I'll try this. I'm going to clear my global environment, including hidden objects. So that this is something that's very useful if you run into any problems and you want to clear your sandbox. You can find the little brush icon in any of the tabs. That just clears everything out. And that's good if you're troubleshooting, because it includes what are called hidden objects. These are maybe things you've defined, little numbers or output you've defined that are hard to get rid of. In technical language, these are called global objects, I believe. It says as opposed to local or private objects. And all that means is you've defined something, but it's not going to go away unless you erase it. And that's a kind of a problem with R. Unlike for a lot of computer programmers, you might define a local object, you'll define it for now. once the script evaluates everything, it vanishes, and then you don't have to clean anything up. In R, if you leave it, it'll stay there. That's why I use the camping analogy. If you're going camping, you want to be a steward of your environments. You want to clean up after yourself. You want to make sure that you probably you clean up after your environment if you're doing these kinds of analyses. So I'm going to actually erase my global environment, and I'm going to actually load. I'm going to open. I'm going to use the drop-down menu just to be careful here. I'm going to open this, and it'll ask us, do we want to open it? Yep, let's do this. And look at that. I didn't encounter any difficulty here because I typed some other parallel syntax that might have slowed down the process. But the point is, use the drop-down menu. Just go up to the top, you'll find it. You're not seeing the drop-down menu because I'm not showing you the full screen, but you will do that. If there's a keyboard shortcut, actually this might even drop down. Yeah, there you go. You can type that little folder there. That will drop it down for you. Okay, and then I showed you how to do the hashtag to comment out questions that or arguments that are no longer necessary. And then you should be able to run the syntax from here. And I'm going to actually move quickly here because this is all pretty automatic. Okay, well, I just evaluated everything. What's important here? Well, this is what we get to when we talk about the course. We want you to evaluate the material in the course. So what we have here is, yeah, we gave you the syntax to understand if you're interested, and I think you should be. I will make an argument that you should be interested in the syntax for evaluating the material. But you should also take a look at the output and evaluate that. And you'll see the output here. And it's beneficial, especially for those of you who are not as used to R, to get used to looking at the output. And much of the numerical output will be presented like this, in terms of numbers with many, many significant digits. I think it's 6 or 7. And then, sorry, I have a notification. And then you have some output presented here. And you'll see many, many decimal places here. And then you'll see, but what you'll see here is that what's the difference between the output that we have as arguments that's written in the script and then the output in the console? Right? How can we distinguish between what we cut, basically I highlight and then I press the run button to run everything. I can do it again. What's the difference here? Okay. Anyone? Okay. I'm not sure if you're not hearing me or not, but the main point is, depending on how you set things up, but typically you'll see your output evaluated right after this little chevron. It'll also be identical to what you have typed in your syntax file here. And it'll be presented as output in black with, hyper precision. I apologize for that. Now, that's what you'll see in terms of numerical output. Now, there's a different thing here going on. Notice we have some things with the plot, with this word plot here. These are other functions. Well, where are the graphs and the plots? Well, this is where I take you to this pane right here. The files pane will show you what files are in your present working directory. Some of these are like saved in memory. These are just, I don't know. This looks like it's in my PDF. These are just in temporary files, autosaves. But what you want to look at are these folders right here. And you can click on that and you'll see, what we have here. You'll see when it was originally created. And then you'll see on the plots pane, you'll see something that's more useful, which is you'll see going from your last plot. So we made 1, 2, 3, 4, 5, 6. You'll see your last of your 6 plots to your first, and you can navigate those by using these little arrow buttons or even a little keyboard shortcut. But let's go back. That was the last one. That was the 5th one. That was the 4th one, 3rd, 2, 1. And did we have another one? Hold on. Maybe I had another one. I guess I didn't see the pie chart here. Did we see a pie chart? Bar graph. Oh, I guess we did. We saw it a little bit farther up. But the point is, these, yeah, we saw the pie chart here in the bar graph. So we actually saw eight plots here. And you can navigate through those. What's common for a lot of students is they won't see their plots because maybe they'll try to evaluate their syntax and look how small I made that pane right here, and I'm going to run this. And they'll tell me, oh, no, I can't run this. And then they'll be like, well, shoot, that's too clever. OK, I'm going to erase those. You should see, if you make your screen too small, you actually won't be able to see your plots. Well, this looks like a software update, actually, since last fall. So kudos to them. Notice I'm keep pressing this little broom here. This clears our environment. But that's essentially how you're going to see and interpret your outputs. You're going to see numerical output here. You're going to see your graphs here represented in reverse order. And these can be exported. OK, I see a server error. I'm not sure what that's from. But you can export these. You can copy to the clipboard, save it as an image. Those are good for basically saving those to either a kind of a working folder if you're writing an analysis, or if you just want to save those for your own notes. Those are useful. You see a couple other files here. I go through in the R tutorials playlist how to deal with or how to work more on the help file here. And then, well, the viewer here isn't that useful. But the main point is you have several panes here, but check out the plots for that output. Check out this for that output. Last thing, and it was actually the first code that we ran, this view function, starting with a capital V. Okay, capital view, and you want to view Titanic. Remember that's a capital V. Why didn't that work? I should actually not. You should, by the way, when you alter your code, you should actually probably do it in the script provided. But the main point is when you run this script, and I'll rerun it. There's no error message now. You'll see what is actually a complete spreadsheet here with all of the definable attributes here. And this is what we call a data frame. It's planar. The variable names are in the columns. The first shaded column is not a variable. It's not in the data set. It is just an index that tells R which observation it is. In technical terms, it's a vector. A vector is just a string of, or I guess a line or a 1 by n dimensional list of words, of numbers, of markers, of indicators that tell us where the observations lie. And that's defined when we upload the data. And you'll see several different variables here. That's essentially where we go from here. But I think for those of you who are very used to Excel, keep in mind the view function is very useful. Okay, so I know we went over, we're about 6 minutes over, but I wanted to emphasize these issues that might seem elementary at first. Because what we essentially did, if we think about, well, what did we accomplish today? Well, we did a couple things. Basically, we basically downloaded, ostensibly downloaded R and .RData files, and and defined their differences. Placed them in the same folder and for future analyses. Learned how to interpret, actually distinguish our output as in numbers and plots. Sometimes when you type in R, by the way, especially if it thinks you're going to do an argument, it'll do an autocomplete. And then we basically learned which parts of the RStudio environment are necessary, sine qua non, for finishing the homework mission. I didn't get to the details here. The devil's in the details. And that's covered more in the, notice I commented all those out. But those points, I think, are terrifically crucial, because this is all you really need if you don't want to use any R. If you're a Python learner and you want to write your final project in Python, go ahead. But this is all you really need to do. And I emphasize, getting started, use drop-down menus. Drop. Now, the last thing I'm going to do is learn to close your assignment once you are done. Right? Let's say you answered all of your questions, you interpreted the output. Now you're done for now. You do want to learn about some of the arguments, some of the nuances here, and we can cover that later. But right now you're, okay, because we're interested in the concepts and in interpretation of raw output and translating that to concepts and to our understanding of statistics, where do we go from now? Well, basically, you want to, what I would do is I always save my syntax. I just do a Command S kind of like impulsively, but I would actually erase your global environments. And if you're done with these, I would put your little broom here, right? That's actually something we learned that I didn't emphasize. We want to do this. I'll ask you, well, you want to erase these from history? Sure. And then you're going to save this and you're going to be in your own environments, but then you're going to close this. You're going to close this. And then you're going to you're going to quit the session. And you can do this right here, but actually we're going to do drop-down menus. So you're going to do File, it's in the upper left-hand corner. You're going to do Quit the session. And it asks, do you want to save your workspace desktop image to this? No, you don't want to save your workspace image. What this says is it's like if you're playing a video game and it asks you to save where you last were. You don't want to save where you were. You want to actually reopen RStudio for the next assignment. Now, if you're still working on this, yes, save it. It'll look exactly like this. But for now, I'm not going to save it. And my screen sharing just closed off from that. So I'm going to reshare the screen because I'm going to reopen RStudio and just show you what it looks like when you're onto your next problem set or problem assignment. I just reopened this and I'm going to share my screen. And if we go to RStudio, you should see this here. This should look exactly how it opened before. There's nothing different here. You are all set for doing everything before. You'll see a history here, but that's not necessary. What you have is you want to make sure your global environment is empty. You want to make sure that your plots are empty. You don't have those. And let's look at those packages. What you'll notice here is that your packages won't be installed, but when you run and open your new code, you can just do File, Open Code once you define your new problem set. And then you're always going to type that ubiquitous command, Mosaic, and it'll do it right here. There you are. Now you're ready to do whatever it is you like to do. So I just showed you how to clean the slate from when you go from one to the next. Thank you very much. Thank you to those of you who stayed on. I'm going to finish this, recording this session, but if there are any other questions for those of you afterwards, please let me know. Thank you very much.